Today's topic is oil and gas prospect risking. When we're evaluating our drilling prospect, there's three things we have to determine. The first thing is, what's the chance of finding oil and gas? How much risk are we taking when we drill the well? Then how much oil and gas will we find if there is oil and gas at the prospect location? And how much profit will we make if we drill the well? So that'd be more into the economics. So today we're going to talk about item number one. How do you determine the chance of finding oil and gas? We call this prospect risking. And it can be complicated and technical, but who does it? Does the geologist do it, the geophysicist, or the reservoir engineer? So depending on the data available, usually you want to have a team effort when you do it. All right, prospect risking. What does it mean? It's determining the chance of success for your well, the chance of finding movable hydrocarbons. We call this P sub S, probability of success, or PG, geologic risk. Sometimes those are interchangeable. We can have PC, which is probability of being a commercial discovery, but we're not going to talk about that one today. All right, so here's our prospect map. It's a 3D seismic structure and amplitude map that we have on our prospect. And there's a lot of data on here, so let's look at some of the data. Okay, we have offset wells right in the area that produce oil and gas, so that's some information that's going to help us. We have the seismic time contours that can indicate the depths of where the high spots are in the reservoir. And we have the color bar for the seismic amplitude, with the bright amplitude being in the red and yellow. And we have our prospect location that we've picked out, the black star. So that's where we want to drill the well. We also have a productive well to the southwest. So that's a lot of information that we can use. Also, we have a seismic cross-section which shows this high area that we're going to be drilling into. So that's something that helps us too, with the faults drawn in red. All right, to estimate the risk, we use a 5 risk factor method. The first factor is reservoir quality rock. Do we have good reservoir rock where we're going to drill the well? We have to determine that. Is there a seal, maybe a shale or something that's going to seal the hydrocarbons from leaking out of the reservoir? So we have to estimate the chance of the seal working. Third thing is the trap. Can we map a trap, with the seismic data or the geology, and is the trap really there, or is there a risk that, we have it misinterpreted? What about the source? Do we have a source bed or hydrocarbon source in the area that could charge up our prospect with the hydrocarbons? And the fifth thing is your timing and migration. So are there migration pathways for the oil to migrate into our prospect? What about the timing? Did the migration happen before the faults in the trap was set up? So you have to understand all that and estimate the chance of these factors. So how did we determine the risk factors? Well, it's based on the quantity and quality of the available data. All right, here's a little matrix that we can sometimes use to help quantify the risk. So we have risk factor here from 10 to 100%, which 100% means a high chance of finding oil and gas, and the 10 or 20% means a low chance of the happening. So you have the outcome, virtually certain to virtually almost impossible, and you have to look at the quantity and quality of data. So it's pretty subjective, but you can look at this, and for each parameter you can see where we are on this scale. But the team has to estimate the probability for each risk factor. All right, so on this project, here's our results of the team's risk factor. We have the reservoir rock quality that we estimate 80% chance of having good rock. And the seal, we have a 90% chance, and that's based on here's the notes that how we based our estimate on. The trap, We have 100% chance on that because we have pay at in the prospect fault block. The source is 100% because we have nearby producing fields, so we know there's a source. And the timing migration is 1.0 or 100% because we have nearby producing fields, so we know that the migration and timing is working. All right, so we've estimated each of these factors for our prospect, and then you have to multiply them together. When you multiply them together, you get the overall chance of success for your project. It's 72%. Okay, so that means for this prospect, we have a chance of finding movable hydrocarbons at the location, and this is a pretty high chance. So this is we're going to drill in a known productive area, so it has a really high chance. Sometimes exploration projects could be 20%, 30% chance. All right. Once you determine the risk of the prospect, you could do some next things to help. You could try to determine how big the hydrocarbons are going to be or how much you're going to find and what's the chance of it being commercial. You do economics, but we'll cover those in another video. And you can look at the risk and unrisked economics. All right, so let's recap. This prospect has a 72% chance of finding movable hydrocarbons at the prospect location, so that's important. Anyway, that's how you do it. And I hope this was informative, and just call me if you have any questions. Thanks.